Record. Hi everyone, this is a addendum to what we were recording before. Steve, thank you for staying on. I'm going to let you do the commentary because you and I saw this and we just kind of went, what? So let's run this first through, okay? What do you think?
Yep, just run it and let everybody see it.
So explain the black dots. These right here. Please pay attention to those. You'll see some down here. Okay, Steve, so everyone saw that. So I'm going to run it. I'm going to stop it right here.
Okay, yep.
So what do we have here? What are these black dots?
Right. So first of all, let's identify what we know is the Earth and Mercury in a retrograde, and that's the way it'll appear from this AHI1 camera, okay? This particular camera picks up polarity, okay? You have to have a lot of energy to show up on this, and nothing in the star field shows up on this. This always shows the coronal ejections and the behavior of the sun, and I've never seen this particular shot where I've seen black dots come out, okay? For us to see those black dots, they would have to be highly charged planetary objects. They could be dwarf planets, they could be any number of things, but the fact that we're counting 1, 2, 3, 4, there's one that's along the bottom there, it's 5.
Yep.
And then you're going to see a 6th one come out of the coronal ejection here in a minute, right?
There it emerges right here.
Yep. And then what you're seeing on the top there, that should be Mars. I'm not sure it is, guys, but that's what it should be. Usually Mars comes out with a really strong line on it, though, just like what you're saying. Holy crap, what is that down in the lower right?
Yeah.
So remember, looking at the, like, if you think about the sun, the Earth is going around the sun, the spacecraft's staying focused on the Earth, and we're flying through space, and basically we're flying through a bunch of planets, dude.
It does seem that way, doesn't it? And what I'm going to do is slow this down a little bit. And what I'm going to take out is the flickering as well. And let's see what happens when we slow this down to 50%. Okay. Then what we're going to do over here, I'm going to go over here, go over here. We're going to take the anti-flickering out. I'm going to take the motion and the spatial blur. Look at there, Steve.
Wow, those are definitely planetary or large objects that are
check
the polarized
out.
Well, there you go, guys. I think what we're seeing here is more evidence that we're in a part of the solar system that could be potentially filled with clouds and planetary objects. There it comes out.
Well, they're certainly showing up on our instruments that, you see, let's explain, everyone. All we should be seeing are our planets, correct?
Yeah, and the coronal,
right, coming off the sun right here.
Yep.
We should not be seeing these. And I just saw that, Steve, and I just thought that that was the weirdest thing right there. I think that's a good one to stop on. So the mystery continues with SECCHI. By the way, did I tell you, Steve, where the name SECCHI came from?
Oh, you did, but go ahead.
Well, everybody, it seems that as the more we get into this, the weirder it gets. It appears that SECCHI is named after a Jesuit priest who was an astronomer, who recorded some very interesting things. And I find it interesting that they named this satellite after that Jesuit priest. Maybe they were looking for something.
Well, again, if it was an astronomer, it was a Jesuit priest. What was he known for? What was his discoveries, or what was his position?
Well, it's very interesting when you do the study on Father SECCHI. I'll just let other people do their homework because, yeah, there's a reason why they named this satellite after him.
And I will say that it's worth your time to find out about Father SECCHI.
Exactly. All right, my friend. Thank you, Steve.
Cheers.